Whenever I was in high school, completing the square was my favorite way to solve these because I didn't love memorizing formulas. And I guess I probably knew quadratic formula, but I didn't really like to do it. So I would use completing the square on lots and lots and lots of problems. We'll see as we go through this that I think sometimes completing the square is a lot easier than using quadratic formula. However, there are going to be some instances where we're going to use completing the square, but it's going to be a little more difficult. Okay, it's currently, I still use it a lot, but not like I used to. There's still some times where quadratic formula will be the best. So whenever we're completing the square, the whole idea is kind of what you were doing last night for homework, is you want to get a perfect square trinomial on one side. Right? So this is what you're going to do. The first thing you're going to do is move the constant to the other side. So the constant is the term without a variable. That's the -1 here. So you're going to have x squared plus 6x equals +1. Make sure whenever you move that 1 over to the other side that you change the sign. And then we are going to add something that will make the left side a perfect square. And this trick here will work always for that. Divide the second term by 2 and square it. I'll let you copy that down, and then we'll do that over here. Okay, so this is a lot like what you did for homework, especially on the back. So you're going to have, what you've got x squared plus 6x, plus you want to add a number here that's going to make that a perfect square trinomial. And if you add a number to one side of the equation, what do you have to do to the other side? You've got to add that same number, right? Because you can't just add something to one side of the equation without also doing it to the other side. So in this case, we're wanting to get this factored so that it's a perfect square trinomial. So what number would I have to add right here? 9. Okay, so 9 is the number that I'm going to add in both of those blanks. You have to add it to both sides. Notice, this always works. Divide the second term by 2, so 6 divided by 2 is 3, and then we square it, which is our 9 right here. Okay? The next thing we're going to do is we're going to write the left side as a square. So this is what you guys were doing last night for homework. You're deciding, is this a square, double square, which it should be if you pick the right number here. All right, so if we factor this, it's going to be x plus 3 squared. And then over here on the right side, 1 plus 9 is 10. So what we've done here is we have made an equation that should be very easy for us to solve. Okay? So our last step is just to solve for x. Once we get that factored, we've made something that we can solve really quickly, because all we need to do here is take the square root of both sides. So we get x plus 3 equals plus or minus the square root of 10. And then to get the x by itself, we just need to move the 3 over to the other side. This is what we usually do when we subtract that 3. You cannot subtract it from the 10 because the 10 is underneath the square root. It's usually written like this: x equals negative 3 plus or minus the square root of 10. They usually put the number first. Technically, you can write it like this: x equals plus or minus the square root of 10 minus 3. That is technically correct, but you hardly ever see answer choices written like that if it's multiple choice or on the answer key or anything. Now, let me try to convince you of why this is better than quadratic formula for this particular problem. It's not always better. So, you don't necessarily have to write this down, but I'm going to solve this using quadratic formula. You can write it down if you want, but you don't have to. So I had x squared, was plus 6x minus 1 equals 0. So if I use quadratic formula, I would have negative 6 plus or minus the square root of 6 squared minus 4 times 6 times negative 1 all over 2. And so that would be negative 6. Yes, thank you. And so I'd have negative 6 plus or minus the square root of 36 plus 4 over 2. And so I've got negative 6 plus or minus the square root of 40 over 2. And now, like, this looks like an answer, but it isn't simplified all the way. It is not. So you got to break down 40. So that's negative 6 plus or minus, we'll have the square root of 4 times 10. So that would be 2 square root of 10. So I've got 2 square root of 10 over 2. And then these three numbers can reduce. I can divide all of them by 2. And so I will get negative 3 plus or minus the square root of 10 over 1. I don't have to write that. All right, which is the same as what I had over here. The reason I like completing the square is because you don't have to simplify in the end for this. Now, that's not the case on every single problem. Some of our problems for completing the square we will have to simplify, but in this case, you don't have to simplify, so it's a little bit easier. And if kids are going to mess up quadratic formula, this is usually where they mess it up, the simplifying. Whereas, like, usually everybody can get to negative 6 plus or minus square root of 40 over 2 pretty easily, and then disasters happen after that. If you do completing the square, you don't have to worry about that simplifying at the end that usually messes kids up. So, hopefully it can help. All right, so now, let's see. I'm actually going to do these a little bit out of order. So I'm going to do this. We'll move these up here. Let me renumber these. Let's make this 1. And this 2. Okay, so another good thing about completing the square. Completing the square works on every single quadratic, just like the quadratic formula. Sometimes it's not the easiest to do, as we'll see in a couple of the later examples, but it works on every single quadratic. So just like quadratic formula, you can use it even if it will not factor, even if it has imaginary solutions. Completing the square always works, as long as you do it right. So number 1 here, we've got 5x squared minus 20x plus 50 equals 0. And we've got a problem here. Because, like, the first thing I did on that last problem is I moved the 50 over, and then I looked for the perfect square. But is 5 a perfect square? It is not. So am I going to be able to write this as a perfect square over here on the left-hand side? I cannot. So, make yourself a note. If you have a coefficient other than 1, gosh, it's just not working today. Okay, so if we have a coefficient other than 1 in front of our x squared, 1 for our x squared term, I should say, divide it off before completing the square. Alright, always. Even if it doesn't go into everything evenly, you always divide it off. Okay, so I'm going to divide by 5, divide by 5, divide by 5, divide by 5. I've divided both sides, everything on both sides by 5, so this is a legal move. Plus, thankfully, it goes into everything evenly here. So I'll have x squared minus 10x plus 10 equals 0. No, 4. Okay, so now we move the 10 over to the other side. And when I do that, I always do this, x squared minus 4x. I go ahead and put me a plus blank right here, equals negative 10 plus blank. And so we need to find a number to add right here. What number is it going to be? It's going to be our 4. This is the way I think of it a lot of times. I know that I'm going to have an x here. Whichever sign you have here, that's going to go here. 4 divided by 2 is going to give me the number that goes right here whenever I'm factoring. And then square, double, square to get this last number. So 2 squared gives me 4. And if I add 4 to one side, I have to add it to the other as well. So I get x minus 2 squared equals negative 6. Okay, questions? Alright, so now we've got an equation that we should be able to solve pretty easily. We're going to square root both sides. So x minus 2 equals plus or minus 6. I cannot take the square root of. I could put the I on the outside since I have a negative 6. And then the last thing I want to do is move that 2. So I get x equals 2 plus or minus I times the square root of 6. I love doing these problems this way because there's nothing to simplify there. It doesn't have anything that needs simplifying. If you had done quadratic formula, you would have to simplify. If you didn't divide off that 5 before you did quadratic formula, you'd have a whole lot to simplify. But even if you divide off the 5, you would still have to simplify whenever you did that quadratic formula. Okay, questions? All right, let's see if you've got it. Try 2 on your own. Okay, look at what you've got. Whenever you do this problem, you'll start by moving the 5 over to the other side. Whenever you are trying to figure out what goes in that blank, 6 this middle term, that's your double. So you've got to undouble it. So 6 divided by 2 is going to give you 3. It's going to keep the same sign as you have here. So negative 6 divided by 2 gives you negative 3. And then it's square, double, square. So you got to square that 3 to get the number that goes here. So that's your 9. You got to add it to both sides. So that gives you x minus 3 squared equals 4. You will square root both sides. And when you square root 4, you get 2, but make sure you put the plus or minus with that 2. And then so you add the 3, move it over here. Since the square root went away in this problem, then you want to give me the final answer. So 3 plus 2 is 5, 3 minus 2 is 1, so 5 and 1 are your answers for this. So if you ever get a problem, and I see this happen very often at all levels, like a lot of kids leave their answer as, 2 plus or minus 6 over 7. All right. I don't want you to, if you've got all numbers, and the square root went away, go ahead and give me the 2 answers for that. Okay? Questions? Now that one would have factored. So if you're getting whole numbers or even fractional numbers as your answers, it means it would have factored. So if I just had this one, in a bunch of problems and nobody was forcing you to use a certain method, factoring would be quickest for that. But quadratic formula, completing the square works no matter what the answer is, even if it would have factored. All right, now, number 1, I would definitely use completing the square on if I just had a list of problems. Number 2, I would have tried to factor. Number 3, I would use quadratic formula if I had the options. Let me make this number 3. I would use quadratic formula if I had the option on number 3. But there are going to be some questions on your test that we're going to have on Friday where you don't have an option, where I tell you that you have to complete the square or factor or use quadratic formula. So you might get something like this that says you've got to complete the square. And I do have reasons for forcing this awful thing right here upon you, because whenever you guys get up, you might do it some in Math 3, but we definitely do it in Math in pre-calculus. When you start doing conic sections, you have to be able to complete the square with any possible equation, no matter what type it is, because it's the only way to do those problems. So it comes back where you've got to use it for all types and not just whatever's easiest. Yeah, it'll be on all quadratic equations. So factoring, factoring, completing the square, and quadratic formula. All of those will be on there. Yes, and I have the review already printed, so if you guys are going to be with ROTC, then make sure you get that before you leave. Okay? Alright, so let's complete the square on this one. Now, if I had the choice, I'd just use quadratic formula, because this one's going to be, yeah, this 3 right here is giving us some trouble, because when you take half of it, it's not a whole number, right? So if you got an even number right here, I usually use completing the square. But this is going to make it more difficult. But we can do it. Also, do not pick up your calculator. The only thing I want you using a calculator for is if you need to simplify the radical at the end and you got a pretty big number. Okay? So fractions, I want these done without the calculator, because you guys are terrible at fractions. I don't mean every single person, but probably most of you are pretty bad at fractions. And the reason you're bad at fractions is because you've been letting the calculator do it for you since you were in 7th grade, right? So the only way to get better at fractions is to make yourself do them by hand, as painful as it may be. And do not use decimals on these, because I do not want decimals underneath the square root. That's not considered the exact answer that I'm looking for. So I do want fractions. So we've got x squared minus 3x plus 9. So the exact same process as all the other problems. It's just a little more difficult because you've got fractions you're going to deal with. So I'm going to have x squared minus 3x plus blank equals negative 9 plus blank. All right. Exact same process. So to get the number that goes right here, I divide 3 by 2. It won't go evenly, so I'm going to just make it negative 3 over 2. Use fractions, don't make it 1.5. So I don't want decimals under my square root, and that's what's going to happen if you use decimals. So 3 over 2 squared is what goes here. What do I get when I square 3 over 2? Not 6/4, 9/4. Make sure you're squaring, not multiplying by 2. So 9/4, but that's really common mistake. So we just square the top, square the bottom. 3 squared is 9, 2 squared is 4. So that's what we're adding to each side. That part, it's not too bad. We can handle this so far, right? Here comes some 5th grade math that is the destruction of us all right here. Right over here, let's put us a thinking bubble. We have got to decide, go ask our 5th grade brothers or sisters how to do negative 9 plus 9/4. Uh-oh. So, right now that's negative 9 over 1, which we cannot add those whenever we have different denominators. So what are we going to use as our common denominator? 4. So we're going to multiply this by 4 on top and bottom. So we get negative 36 over 4 plus 9 over 4. And so when we do that, negative 36 plus 9 is negative 27 over 4. Oh, we can do it. Leave it as an improper fraction, yeah. We will, pretty much from here on out, we would rather have improper fractions than a mixed number, as far as making it easier to work the problem out. breath, we just added fractions all by ourselves. Isn't that exciting? Nobody lost a limb or put out an eye, had an anxiety attack yet. So now we're solving this just like we did the other problems, okay? So we're going to square root both sides, okay? So over here, that just cancels the square, so we've got x minus 3 halves equals. And now, when we square root a fraction, we're going to square root the top, and we're going to square root the bottom. But we square root of negative 27, we're going to have to break that down. We can't do square root of negative 27. So, what will that break down into? 9 and 3, so we'll have negative 1, 9, and 3. So we'll get 3i times the square root of 3. Alright, so on the top, we'll have 3i square root of 3. On the bottom, what's the square root of 4? Square root of 4? 2. Alright, and put a plus or minus here. Hello? Hey. Uh-huh. I think so. But I'd have to go look. I can't remember. It seems like they've done crazy stuff. Like said you only had to have exponent like a 1/5 or 1/6, and then they put like something to the negative 3 halves on there or something. But I'm not sure. Yeah. I'll go back and look through my stuff during planning this afternoon and see if I can. Yeah. Gosh. I know. And there's like a million of them. Yeah. So I'll go back and look and see if I can remember what it. I think I did it with my kids this year, but now whether or not I was supposed to, I don't really know. Okay. Yeah. Yeah, might as well. Alright, thanks. Bye. Alright, sorry. Okay, alright, we're almost done. So, last step, we're going to add the 3 halves over to the other side. So this is going to be x equals 3 halves plus or minus 3i square root of 3 all over 2. Notice those have common denominators. You have 2's in the bottom of both of those. So if we want, we can write it like this, 3 plus or minus 3i square root of 3 all over 2. That looks an awful lot like a quadratic formula answer, doesn't it? So this gives you the same thing you get if you did a quadratic formula. Is everybody okay? Anybody need a Valium or something? You okay? All right. Yes. It is easier. It is easier to do quadratic formula, and if nobody tells you what you have to do, use quadratic formula on that one. Yeah, but this one says you have to complete the square, so you have to complete the square. And there will be a few on the test like that. There will also be several that I'll let you use whatever you would like. Yes. Yeah, something like this might show up, yes. Yeah, you can do it. Nothing we did was that bad. You just gotta take your time and you gotta do it. One like this would not be necessarily. If the numbers get bigger, maybe. But one like this, I definitely will put you at least one like this because none of the numbers get that big here. One like this could definitely be on calculator inactive. When you're doing your homework, do not use your calculator for your fractions. The only thing I want you using that calculator for is for big numbers that you need to break down. Alright? So, write it out to the side because the only way you can get better at those fractions is if you actually do them yourself. You can do it because, I mean, this right here, what probably gave us would give us the most trouble right here, you learned how to do when, well, there probably wasn't a negative with it. It was probably both positive. But you learned how to do this when you were in the 5th grade. And you could probably do it fairly well in the 5th, 6th grade, right? But you have since relied on the calculator until you have no clue. I will admit, I was an excellent math student. I loved math. And when I was in like 9th, 10th grade, I didn't know how to do fractions very well by hand. But I had a Algebra 2 teacher that really stressed it, and once you get the hang of it, then really they're not that bad. Most of the time, by the time I get my kids to like the end of pre-cal or in calculus, they finally believe me that the fractions are not going to kill them and that they might actually make it. But usually it's tough to get to that point because most people have an aversion to fractions. All right, let's do another one. And notice, everything we did, the process is exactly the same as the easier problems. Process is exactly the same. It's just you got to stop, think, go over to the side, work this out, add these fractions, simplify this radical. But it's the same process as the other problems. Now, number 4, we've got 2x squared minus 8x plus 9. What are we going to have to do first here? Well, before I move the 9, there's something else I've got to do. I've got to divide by 2 because you can't complete the square when you've got that number in front of your x squared. And notice, on the first problem we did, it went into everything evenly. So that was okay, right? Does it go into everything evenly here? No. Alright, so we're going to have x squared minus 4x plus 9 halves equals 0. Okay, so I'm going to have x squared minus 4x plus blank equals negative 9 halves. Oh, yes, we should. Thank you. I need to put a blank right there. Now, but fortunately, we at least have an even number over here, right? So I'm not going to have a fraction in both places, although you might have some that happens with, but I'm not going to have a fraction in both places here. So whenever I factor this, I'm going to have x minus, what number goes down here? It's going to be a 2, right? Half of 4. What number do I add in the blank? 4. 2 squared is 4. Okay, so take a deep breath. You can do this. Summon your inner 5th grade students that knew how to do this long ago. Alright, negative 9 halves plus 4. Alright, that's 4 over 1. What's your common denominator? 2. So we'll have negative 9 halves plus 8 halves. And what will we get when we add those together? 9's negative. Negative 1 half. Alright, so we'll have negative 1 half. Made it. Okay. Alright, so now we've got an equation we can solve. We're going to square root both sides. So over here, I'll just have x minus 2. Take a deep breath again. Because I've got square root of negative 1 over 2. Here's the problem with that. Can I take the square root of either one of those? I cannot. But this is something that I would like for you to do. You don't necessarily have to do it always, but most of the time our Answer keys do not like to leave a square root in the bottom of a fraction. So let's think about this for a second. I've got negative 1/2. Right? Could I multiply 2 by something to get it where I could take the square root of it? 2, right? So what if I made this the square root of negative 2 over 4? Is that still the same? Okay, so now I could take the square root of negative 2, which I still can't take the square root of 2, but that's okay. I could just make it I square root of 2. But at least on the bottom, what do I get on the bottom? Just a 2, right? That way, I don't have a square root in the bottom. Your answer key normally is not going to leave a square root in the bottom of a fraction. So whenever that happens, try multiplying your equation by something that'll give you a perfect square in the bottom. Make sure it's still equivalent. You got to multiply top and bottom of that number. And so we'll have a plus or minus here, I square root of 2 over 2. We're almost there. We're going to get x equals 2 plus or minus I square root of 2 over 2. Now, I'm perfectly okay if it's on your test that you guys will have on Friday. You have a few multiple choice, but most of them, it's going to be paper pencil, and most of them are ones you just work out the problem. So it's perfectly fine with me if I've told you to complete the square. You can leave your answer like this. But when you take your final exam in this class, everything's multiple choice. So if they give you something like this, there's a good chance they may not write your answer like this. So these don't have common denominators. We could get common denominators if we wanted to, right? So if we wanted to get common denominators, I would have to multiply by 2 on the top and bottom here, right, to make that so that both of the denominators are 2. So that would be 4 halves plus or minus I square root of 2 over 2. And then since they have common denominators, I could write it like this, 4 plus or minus I square root of 2 over 2. There's a few multiple choice on there, but most of them are ones where you'll just work out the problem. Okay, and if you're just working out the problem, leave it like this. I don't care if you did this. The main reason I'm showing you this is in case you were to see something that was multiple choice, or as you check your answers on your homework tonight, they're probably going to look like this instead. So you'll know, even though you got this, it is the same as this over here. Yes, I would. Yeah. Okay, questions? All right. This is all today.